Good evening and welcome. Thanks for coming in. Oracle to SQL Migration Beyond SSMA. SSMA stands for SQL Server Migration Assistant. Before I begin, a quick show of hands. How many of you have at least heard about SSMA? Fantastic. And okay, can you please keep your hands up? I won't make it too long. And how many of you have done some POC with SSMA? I mean, you have tried stuff with SSMA. Okay. How many of you have done actual migrations using SSMA? Okay. A few of you. That's good to see. So my session beyond SSMA is about things that you cannot achieve using SSMA. I want to truly stick to the title of the session, which is Oracle to SQL migration could be considered as any other project, which has your design phase, planning phase, your execution, remediate, deployment, cutover, etc., etc. But SSMA is a wonderful tool, but there are things that SSMA cannot achieve for you, and you need to do it manually. Today, next 45 minutes, I'm going to show you those things that you need to take care of, at least those common problems that you come across when you move data schema from Oracle to SQL. So we will definitely use SSMA, but you will see that SSMA in certain places will not be very helpful, and you have to do those things manually. Now, the slides have a lot of reference about Oracle to SQL migration as a project and the life cycle of migration. So I'm going to skip those slides and jump straight into demos. So the focus is going to be on a few things that I am going to talk about, and let me straight away come to the agenda, which will be based on the demos. So these are the things that I'm going to show you today, and slides before that were all about basics about SSMA. You can get a lot of tutorials and step-by-step wizards, articles about SSMA on Microsoft documentation site. These are the things that I'm going to focus on, where SSMA will not be very helpful and you have to do things manually. So we are going to talk about data type mappings. SSMA does a very good job, but there are things that you need to take care of specifically when it comes to date time and varchar. I will talk about dynamic SQL, user-defined types. SSMA has no support for dynamic SQL and user-defined types. We will also talk about transactional context between Oracle and SQL and where you need to focus on. Nested PL SQL subprograms and user-defined functions. There are a few things that you need to know about them as well when you're working on an Oracle to SQL migration project. So these are things that Bing cannot find for you. I know Bing is your favorite search engine. So let's get started with the first one, data type mappings. When it comes to numeric data types, SSMA does fairly a good job. Between Oracle and SQL, there are dissimilarities, but there are a lot of similarities as well. So if you see number is mapped well to numeric. If you have number with precision and scale, it's mapped to numeric precision and scale. Likewise, number with only precision is mapped to numeric with precision, so on and so forth. What you need to take care about is in SSMA, when you have a number, do not change the data type mapping to a smaller value like a small int or number with a length, let's say number 20. If you do that, and if your values are higher than the target data type, there will be truncation. To be on the safer side, sometimes you might want to map number to big int. I'll show that to you in a moment. In data type mappings, date time is something that we have come across quite often, and there are certain challenges to be taken care of. So let me give you some background. We work closely with Microsoft, and we have helped a couple of customers move from Oracle to SQL. I have been part of those migration projects. And we faced certain challenges with date time. Now, Oracle has two data types that you need to know. One is date and timestamp. Both date and timestamp, they map to SQL Server's date time 2 data type. Now, all of you know in SQL Server, we have date time and date time 2. So date time 2 is the older one that we had prior to 2008, but starting from 2008, we had date time 2. Date time only supported, if you look at the first one, a range from 1st January 1753 to 31st December 9999. That's the Gregorian calendar that datetime follows. Datetime too has a higher precision. But Oracle's date goes even beyond, and it starts from 4712 BC. That's really far. If you have an application that actually needs that kind of support, then SQL will not be able to support that. Then you will have to work with varchar and convert it back. There's another thing that you need to know about datetime. Oracle would have support for up to 7 decimal places in terms of nanosecond support. SQL will only support up to 100 nanoseconds. So in case if you have a value which actually goes after milliseconds, goes 7 digits with nanosecond precision, that value will get truncated in SQL. In most business applications, converting back to 100 nanosecond precision is acceptable, but that really depends on what the business type is. Oracle has a data type called interval. Unfortunately, SQL Server does not have this data type. So there is no support in SQL for interval, and likewise, SSMA would completely ignore this. So if you're actually converting an Oracle table that has a column which is of interval data type and you move to SQL, Oracle will, SSMA will just convert it to varchar. Now what really interval is, in Oracle you could actually have a column with data type interval, and you can say interval means what is the interval between 2 date ranges. Let's say the start and the end date. So you could say the interval is 2 years, 4 months, or 3 years, 8 months. This is how you could specify it in Oracle. So my first demo is to show you how you could deal with these two things, date time. So I'm going to focus on date time first. So let's switch to the demo, which is. So let me explain you the setup. I have Oracle 10G installed, where I have a database, a schema called HR. You know, schema in Oracle would map to database in SQL Server. And on the other side, I have SQL Server 2016. And in between sits SSMA. So I've already created a project just to save some time, where we will move data from schema and data from Oracle to SQL. And as I said, SSMA is just a kind of a medium to create the project, but everything else will be done manually because the session is beyond SSMA. So let's go to tables, and I have a table here called region. And if you look at region, it has region ID, region name, and area. I'm going to create a column here, and let's call this column as TS. Data type will be timestamp, and let me apply. So I've created a column with data type timestamp, and I am going to create another column, and this time this is going to be interval, so I'll just name it as DTINT. And if you see, interval has 2 variations here, interval day to second, interval year to month. So I will choose interval year to month. To remind you again, there is no support in SSMA or SQL for interval date type. Now we go to the data section, and you will see that let me just zoom it out a bit. For timestamp and interval, these two I have null. So I'll just enter some data here. And this is what the data looks like. So 1, 2, 3, 4, 5, 6. So precision, right? I would just put 1, 2, 3, 4, 5, 6. This is the nanosecond precision that you want to put. And I will show you how it gets truncated. Okay, and in interval, I will enter, let's say, 2 years, 4 months. That's my interval. Look at this, how the data gets stored in Oracle, which is +2, 4, which means 2 years, 4 months. So in total, if you run a script, it would probably show you 26 months of interval. Let's commit these changes. Okay, committed. Now, I'm using SSMA to move schema and data. So I'll just quickly do 4-part process, which is first I will refresh the schema from Oracle because I've made changes. And then I am going to convert the schema, which is overwrite everything that I have in the project on SQL side of things. So after refreshing, it writes it here. And then on my SQL metadata explorer, I am going to synchronize with my target instance of SQL. And when it synchronizes, obviously it's going to detect the change that regions table has some changes, and as you expand, you could clearly see under HR, under tables, you will see region has some changes. Click on OK, and it would do the job for you. The final step here would be to migrate the data after you synchronize. So stuck up at 96%. When I refresh, and if I look into HR, here are all the tables that are deployed. Back to the project, okay. Still at 96%, okay, 98%, done. And now we will migrate data. So I right click and migrate data. I will connect to Oracle and SQL and move the data. So what I want to show you now is we added this. So now we have the data, and let's take a new query. And we have from regions. What do we get? First thing you will notice that the data gets truncated. You have up to 100 nanosecond precision, so you only get 0.86 millisecond and nanosecond 1, 2, 3. Remaining portion gets truncated. So this is one thing that you need to take care of. The second thing, if you see here, is interval. Now, SQL Server, as I said, has absolutely no substitute to interval. There's no counterpart in SQL for interval. So this is actually treated inside SQL Server as varchar. And if you actually right-click here and get into the design of the table, you will see what SSMA has done. It has converted this into a varchar. Now the problem is application. The application which is writing or coding against interval date type. How do you need to deal with this? This has to be done manually, so you may probably write a routine, a procedure, or a function that will take this data as a varchar, parse it, convert it into integer, and do whatever mathematics you want out of it to give you the actual interval value. So let me show you a small prototype of that, which I've created. So here is a procedure. Let me create this. Create procedure which called parse interval. It takes the value and does a simple mathematics around this. Okay, it's already there, wonderful. Okay, so this is what I'm going to do. So our value there is 24, right? And when I run this, you would see interval in months is 28. So 2 years, 24 months, plus 4, 28 months. These are things that needs to be done manually when you are moving from Oracle to SQL. So if you have databases, applications that are actually using interval data type, you have to write manual routines and code to work with them when you move from SQL side. Okay. Now, next is varchar. So again, varchar2 and character data and varchar, they all map pretty well with SQL here. But two things to note, which I've put down as a note there. If PL SQL variable is declared with a constant size greater than 8,000, SSMA maps it to varchar max. That's one thing. The other one is formal parameter. If you have a stored procedure which takes varchar as input parameter and does not specify a length, then SSMA would convert it again to varchar max. Now, varchar max, what do you make out of it? Is it acceptable to you that you have all your stored procedures, for example, taking varchar instead of a fixed length, you accept max? Max means you can go up to 2 GB. So let me show you a code, and then I will take some feedback from you. Look at this code. What is the problem with this code? Anyone? By the way, this is Oracle code. I've opened it up in SQL. It won't run, but just showing it to you. What's the problem with this one? So this will, two things. if I take this code and I create a procedure now, so let's go to procedure and create a new procedure. So in Oracle, it's not mandatory for you to specify a length for your input parameter. That's the difference between Oracle and SQL. Instead, if you actually try to put a length here, a precision, the code will not compile and it won't run. But SQL, on the other hand, needs you to specify a length. You just can't say varchar, you need to specify a length. So see what happens now. When I create this, okay, is it done? Test varchar2 is created, and so this code is created, and if I go to SSMA and I refresh from database, nothing to refresh. If I expand procedures, okay, and I create a report. Do you see the difference here? What SSMA does? Let me zoom in a bit if I can. Okay, let me do this. Okay, so this is how it was in okay, this is how it is in SQL Oracle, and see what it does here on the SQL side of things. It actually adds max. Now, if we convert this to SQL Server, everything will run absolutely fine in SQL. The only problem is the stored procedure is now going to have max as an input. Is it acceptable to you, a stored procedure which takes max as an input? So there is a performance implication to this now. And this actually comes from the fact that when we were doing a few POCs and prototypes for customers complained about performance issues. And the reason was because of max. So let me show you a quick thing. When this piece of code is moved to SQL, this is how it's going to come. Test varchar max, and everything is going to run fine. But what you need to fix is, instead of max, you know your application, you got to give specific length to the data type to ensure performance. And when I say performance, what exactly do I mean? So here is a small demonstration to show you. If it's actually max, and I'm going to show you what's the difference between max and giving a specific length to the data type. So when I run this piece of code, which is actually dealing with max data type, see how much time it takes. When this piece of code is running, it would take about 5.8 seconds. And when I specify max is max, I mean, and I will tell you why it works this way. I specify a precision, a length to the data type, and when I run this will complete in 2.8 seconds. 2.8 seconds versus 5.8 seconds. Now, inside SQL Server, max, varchar max is treated differently. So fixed length is treated differently. There's a separate code path for max, and that is the reason why you should always specify the length. So this is another thing that you need to take care of when you're moving from Oracle to SQL. SSMA by default would just put max as the, will suffix max with the varchar data type. Is it making sense? Yeah? Okay. So date time, interval data type, the manual things that you need to do, then we dealt with varchar. Next is dynamic SQL. Now SSMA obviously has no support for dynamic SQL because simple reason, the code is not known until runtime. So SQL will just comment it out, convert the execute immediate to execute statement of SQL, and then you have to deal with it manually. Okay. So here is another demo for dynamic SQL. Let me close this. So let's say this is this is the code, and I am going to create a new stored procedure. Let me create a new stored procedure. Okay, create or replace procedure 1. I think I already have that. And this is one. Okay, execute immediate. So this is my dynamic SQL, and when I go to SSMA and I look at procedure, you already see that it has a cross here, which means it clearly says that it won't be able to convert this. So if I just look at the report for this procedure, allow blocked content, and this is how it would come. So execute immediate statement was converted to execute, etc., but dynamic string was not converted. It must be converted manually. Now this needs to be done manually. And now looking at the statement, whatever it is, let's say execute, you're trying to create a table inside the stored procedure, so that needs to be done manually. So when we move to SQL Server after modification, this is what you could actually do. So this is the piece of code, and all you have to do is manually convert this, which is, so let me quickly take the converted version already. This is one, execute select star into HR. So create table statement is again needs to be changed to select star into the new table from HR region. So this is the line of code that you wanted to write. And execute this. That's pretty much it. And you execute the stored procedure. Okay, there's already an object. So my HR, let me just drop this. Works fine. Right, so again, quick recap, dynamic SQL is not supported by SSMA, and you need to do that manually. Sorry. Yeah, yes, question, please.
Yeah, so this seems to me like could be automated at some point, right? Because it's quite straightforward what you do.
So as you know, dynamic SQL cannot be quite straightforward because there's a limitation. Yeah, I don't really see dynamic SQL to any solution with dynamic SQL. Other things that I showed at some point, as Microsoft works more on the tool, they will come up with fixes. Not really fixes, but improvements. But dynamic SQL could probably stay the way it is, right? Okay, so next one is user-defined types. Now again, user-defined types, there is absolutely no support with SSMA, and you have to again do it manually. And this could be just a very quick demo where I will show you that there is a UDT already in Oracle here in my HR schema. If I go to types, this is the UDT that is there. SSMA would fail to recognize person as, because it just declares as a generic object. And when you go to SSMA project, and let's expand, if you look at the report, if I look at the final report, I mean a complete report of HR schema, and user-defined types here shows that there is absolutely no support, and you click on this, no support. So what you got to do? This is how it looks like in Oracle. Nothing doing, you just have to rewrite this manually in SQL Server. If your Oracle has UDTs, you have to convert them manually using tSQL. So here if you see row, Oracle by default has a row ID. I'm sure all of you know this, right, with the object. So you have to declare this manually, and we can use new ID function to get GUID into this column, row ID, and you have to declare a primary key. So create type person OT as table. This also needs to be done manually. Okay, so.
But this would also imply then that your application can also redefine queries, right?
Come again, sorry?
So this example would also imply that the application queries, so to say, they also need to be adjusted, right?
So if you see, the application would work there will be no breaking changes in the application here, because when you look at this object, it was actually a table, column with data type and the precision and the length. So you know you need to declare this unity as a table. So it would work absolutely fine there. So his previous question, sorry I did not repeat this. This previous question was about dynamic SQL. So dynamic SQL, I don't see any support happening because it's an architectural challenge here that you don't know the code until runtime. So SSMA will probably not have any support for it. And his second question was about unities. So there shouldn't be any application break here because we know that it's an object which is actually a table. So you rewrite that in SQL Server, create unity as a table. Next is transactional context. Now, for this, I need to give you some background between Oracle and SQL. Oracle traditionally follows optimistic concurrency model, which is writers will block readers. Writers will not block readers. And in SQL Server follows pessimistic concurrency model, where writers will block readers. So how do you deal with this situation? You know, from SQL 2005 onwards, SQL Server had snapshot isolation, which means with SQL Server you can also implement optimistic concurrency model. But even though SQL Server supports optimistic concurrency model, there are a few things that we need to know. And I will come to the summary in a while. For transactional context, I will spend some time. Let me show you the code first now. Next demo on transactional context. So if you look at this piece of code, and let me put this in, do I have a procedure here? Okay, let me create a new procedure. So insert, so let me first cut, sorry. I will actually first create a quick table. Okay. I'm creating a table, HR test, okay, and then I am going to create a routine, a procedure, and this is my procedure. What is this procedure doing? Very simple. This store procedure just simply inserts a record into this table, right? And look at this statement, commit. Now my question to you is, in SQL Server, do you explicitly need to pen down commit? Do you need to write commit after the statement? You don't need to do that in SQL Server. SQL Server has implicit transaction, which means it is like begin, insert, and commit, and it is automatic. But in Oracle, you need to actually commit. If you don't do that, there is a possibility that you can roll back. Now, so this behavior, so if I create this proc, okay, and let me refresh. So my insert proc is available, and I have already done the migration, so I will show you this piece of work in HR. Okay, this is how it will come in SQL now. Now I think the latest version of SSMA 7.6 probably has already taken care of this, but let me give you the background to it. It's the same procedure now, but now in SQL, how does it come? Insert, and then you have commit work. Now if you run this stored procedure, what do you think? Will it run fine or will it throw an error? This will actually throw an error. If you try to execute this, it gives you the commit transaction request has no corresponding begin transaction, simply because this in SQL is treated as an implicit transaction. So to fix some of these things, what you could do is set implicit, okay, that's already there. So you could either do it this way. For this particular session, you can set implicit transaction to be on, which means now every time you are manually beginning a transaction and you are committing it. So now if you execute this, it would run fine. That's one way of doing it. The other way is, let me turn this back off, and I can say if at the rate try and count greater than 0, and then I can say commit work, and I can alter the stored procedure. In such a case, I'm actually checking if, because if implicit transaction is off, and this means an implicit transaction, which means begin, insert, and commit, which means try and count after commit will always be 0. So it's not going to be greater than 0, which means this statement is not going to fire. So with this off, and if I run the stored procedure, execute the stored procedure, it should insert the row.
Why not remove the whole thing?
Yeah, you could do that also. Or the best way is, between Oracle and SQL, as I've seen. As you know, there is a database setting called allow snapshot isolation to be on, which will mimic complete optimistic behavior, right? Read committed isolation level will become read committed snapshot. So the point is, either way, manual intervention is required, whether you remove commit completely or you want to mimic the same behavior as Oracle, so you turn implicit transaction on, or just change the isolation model completely from pessimistic to optimistic. However, doing the last thing, which is moving from pessimistic to optimistic, is not very straightforward. There could be a lot of implications on the application. Think about it, an application where there's so many transactions going on, and the behavior that users are expecting is that writers will block readers, right? And then you move from pessimistic to optimistic, you get a completely different behavior where writers will not block readers. So it's not a small change. All right, so that was about transactional context. Nested PL/SQL subprograms. Now, these are things where SSMA does a good job. There are two things. One is, in Oracle, you could actually define a procedure inside another procedure, right? SQL does not have such a concept. So when you have a stored procedure like that, what would SSMA do? There are two options. One is inline. It actually, so let's say there's procedure 1, and inside procedure 1 you have another called procedure 2. What SSMA will do with inline option, SSMA will take the logic of procedure 2 and embed it in procedure 1 and create a long procedure. That's one option. The other option is separate stored procedure, which means it's going to modularize it, which is it would create procedure 1 as separate, it will create procedure 2 as separate, and then it will create a calling procedure, which will call proc1 and proc2. So I have practically seen that separate stored procedure, the second option works better because the code gets very modular, and more so when the business logic is complicated, and if everything is merged into a single proc, it just becomes very difficult to debug and to make any changes to the proc. So let me quickly show you that option. So there you go. This is the stored procedure that I will create in, do I have this already? 1 second, procedure, new procedure. Now, if you see proc1, right, it has proc2 inside it, and then it has proc3 inside it, right? So 3 together, that Oracle allows you to create something like this, which SQL has no support for. When you go to SSMA and you look at procedures, here is your proc1. Let's go and create a report for proc1 and see what it does. So if you see what has, let me just close this a bit. What has SSMA done? So you have proc1, and then you execute proc2 and proc3, and proc2 is defined separately and proc3 is defined separately. Okay, so there you go. This is separate, and as you go up here, you have this as separate, and things work fairly fine. Yes, when you move these procedures, when they finally executed in SQL, of course, depending on how complex the business logic is and what dialects are you using, because PL SQL versus tSQL, there are notable differences. SSMA does a good job in converting the business logic, but there we have practically seen that you may have to intervene in a couple of places. So it's not that you take a very complicated long stored procedure, use SSMA, and everything is very honky-dory, moves, migrates very nicely, and things keep running absolutely fine in SQL. Doesn't really happen that way. Manual intervention is required. And yeah, the option, if you prefer the inline option, which is proc 1, 2, and 3 is merged into a single proc, then in SSMA, you just need to go to Tools, Project Settings, and here, there will be an option, yeah, local module conversion. If you see local, this is the option here. It says stored procedure, and the other option actually is inline. Yeah. So depending on what you prefer, you could choose that. Okay. User-defined functions. Again, in terms of similarities between Oracle and SQL, I have seen less breaking changes with functions. Works very seamlessly, but there are again a few things. In SQL Server, from a function, you cannot call a stored procedure, right? In SQL Server functions, you can't even have DML statements. Oracle would permit things like that. So if you actually have a function in Oracle which is actually calling a stored procedure, and you try to migrate that from Oracle to SQL, how will SSMA treat it? Again, less manual intervention is required. You just need to be aware of the fact that the body of the function actually is going to be created as a stored procedure, right? And you will have another function created which is going to call that stored procedure using an extended stored procedure which is part of SSMA package. Okay, so this is something that is done, and I will quickly show you an example of that. So here is the piece of code for function. Now look at this function, and of course it won't run in SQL, but you can understand that you have a function which is calling a procedure, right? The function is function 1, and how is SSMA treating it? So if I go to functions here, function 1, and let me create a report of this. There you go. Look at what this has done. You're calling so create procedure. So a procedure is created, which is actually the body, the implementation of the function, and this is called by another function, which is here, HR function 1. And how is it calling the previous stored procedure? It's using an extended stored procedure which is part of SSMA package. This is how it is implemented. So, I mean, of course, if all these things are first time for you, they will look a bit complicated, but with simple academic prototypes, the way I've created, we test things out to see how it will work, and then we do the test with migrating real schema and real data. There are a few other things, many other things actually, but I've put only few of them on the slide. Jobs, packages, system views, they're all, SSMA can help you move jobs, packages, and system views also. And for jobs, again, add job, drop job, add job step, all that is leveraged by SSMA. Likewise for packages, and because packages, for example, SQL Server does not have any direct support for Oracle packages. So all that is a bit of manual work there as well. 7.3, SSMA 7.3 has a new functionality, Microsoft Extensibility Framework. This conversion that SSMA is doing, sitting in middle from Oracle to SQL, that API, good thing is that with version 7.3, Microsoft has exposed some of this functionality to you. And what you could do is libraries are exposed. So you could actually write your own conversion code if you want. And how could you do that? You, like, for example, go to Visual Studio, create a new blank class library project, add the namespaces, Microsoft.SSMA and a couple of them, and then start leveraging those APIs. You compile the project, you get the DLL, and you take the DLL and put it into SSMA folder. So now instead of SSMA default logic, your DLL, your code can execute. This is a very advanced way of how you can customize conversion from Oracle to SQL. The program team at Microsoft has also blogged about it. So if you go to the default official SSMA blog, you could see a small example out there. No more demos. So hope this was useful to all of you, right? I tried to cover a few practical things that you need to take care of. So if there are no further questions, please evaluate the session, give your feedback. And thank you very much. Hope this was worth your time, and have a wonderful evening.